Thank you very much. So I'm going to present in front of you what it's like to live in space, or at least how we can see it from our model, which is RPM simulated microgravity, and that we use in our university, which is Medical University-Plovdiv. So I would like to thank you for this kind of opportunity to show our work here, and I would like to start my presentation with the next quote from Carl Sagan, which is the following: "Space is for questioning and wondering, for exploring the unanswered questions about the universe and ourselves." So this quote shows that the humanity is curious by its nature, and one of the most interesting things is to explore the cosmos. But what is the cosmos? So if we want to summarize it pretty roughly, that it's a combination of celestial bodies, objects, radiation, and empty space. Now, empty space, we have a lack of a dominant gravity, and that lack of gravity can create quite serious problems on the human health. So let's see how it affects the human health, or at least what we know up to now. So we can find that microgravity can induce some morphological changes in the heart, but not only in the heart, in brain as well. Also, it changes the heart rate, the blood vessels diameter, and the vascular smooth muscle contractility. Regarding the bigger muscle groups, we talk about skeletal muscles here. We found out change not only in the muscle tone, but we found out change in the strength, also the bone density, and we also have premature osteoporic changes in the human body, with an increased height of the astronauts, especially after long missions. When we talk about the nervous system, we found out that we have lack of sleep of astronauts, difficulties in communication, and in animal models, we even can find out aggression. Also, quite difficult tasks, quite a lot of tasks are finding difficulties in different microgravity conditions. Last but not least is the gastrointestinal tract, in which we can find changes in the smooth muscle contractions, which are very important for the peristaltics, and also changes in the mucosal barrier function, which could lead to very serious health damages. More or less, we also have a reduced energy intake and a weight loss, not only in astronauts, but all kinds of animals that have been floating in space. So we have several ways how to test microgravity, and one of the first things is to test, of course, in real space conditions, which, of course, it has its pros and cons. But one of the interesting new kind of experiments that are done are those which are simulating microgravity, or the effects from microgravity, and those we can recreate microgravities in short term. For the first one, which we can recreate the microgravity effects, for the animal models, those are the hind lip unloading. Very modern is also the random positioning machine, or RPM, on which I will pay more attention in the next few slides. The head tilt best rest is one of the human tests that we use here on Earth, and also the dry immersion that again can recreate microgravity effects here on Earth. The recreation of real microgravity on Earth can be done only with the following three experiments, or at least up to now. Those are the parabolic flights, sound rockets, and drop towels. As I said, I will focus today on the random positioning machine, which our team used for simulating microgravity on the rats. For the purpose, we developed a special prototype that you can see on the right side of the slide. It is consisted with two metallic frames. Each frame is perpendicular to the other one, and their rotation is in two different dimensions which are perpendicular to each other and they're independent from each other. In that way, the RPM machine redistributes the gravitational vector, and if you look at in 3 dimensions how it looks like, it should normally distribute evenly to the whole surface area on a virtual sphere. If that is true, we're going to have better simulated microgravity distribution. Better if it's more randomly distributed, better the microgravity simulation is going to be. So we use that model to present the results on the next slide. But if you need more details of how the machine is working, you can find out on the following papers that I give. Of course, those are just some of them. You can find a lot of information on that in the scientific journals. On the next slide, you can see the block scheme of our experiments. So we used male Wistar rats and we randomly assigned them to 3 groups. The first groups that we named at RPM was subjected to the simulated microgravity with the prototype, and to it we had 2 controls. RPM-K is the control group of the RPM machine, so to adjust and to tell what is the effects from machine itself without simulating microgravity. And of course, we had pure controls. With that, we did the experiments and we obtained the results that you're going to see on the next few slides. So we found out that the RPM significantly reduced the mass of the subjects, and in that case, those rats which were subjected to it. Nonetheless, we also did some kind of psychological tests, and we found out that the RPM group had a lower levels of psychological stress compared to animals which were from the 2 control groups. Furthermore, we found out that we had changes in the kinetics and how fast inflammatory responses were happening in the 3 groups. And in the RPM group, we found out that there is a delay in the first hours to the inflammatory response due to the simulated microgravity, which later catch on with the 2 control groups. Of course, for more details, you can refer again to the paper that I have give here. So to be very more details. So on the next slide, we can see that the RPM simulated microgravity induced an increased acetylcholine esterase and a decrease in some markers for oxidative stress in the hippocampus of the experimental animals. Some of them we attached that and we saw we had problems and we had an increased number of alpha-7 N-type of acetylcholine receptors in the same area of the rats which were subjected to the microgravity. And what is important about that receptor, it is connected with the memory, especially long-term memory in them, which found out that that increase was trying to compensate the deficiency in memory that we found with other memory tests. One of it, which is shown on the slide, is called Shuttle Box, and it is to test the long-term memory and long-term function of the rat's memory. Regarding the gastrointestinal tract, we found out the simulated microgravity changes the kinetics of it by slowing it down, and you can see it from the picture that on the 4th hour, the control groups have faster and better peristaltic activities compared to the animals subjected to the simulated microgravity. One of the reasons for that may be the smaller response to dopamine that we can see on the graph on the right, and due to that, this slows down the whole peristaltics. At last, let me summarize the main points of our model. And one of it is that it brings up accuracy because some of the results that we obtain are already observable in astronauts in real space conditions, which makes the model very accurate. And that leads to the next bullet, which is the predictability. With it, we can use it to predict what kind of a future physiological and psychological, in combination, of course, of them, can be in danger for a future astronauts, especially in long-term missions. Furthermore, details of the physiological conditions can be explained in details with the animal model, because we have the opportunity to test not only uh, markers for it, but also some mechanisms and cellular paths on how a specific condition develops. However, we always have to treat that with caution, because extrapolation of the results from a rat or any other kind of animal to human should be made with quite great caution. And of course, we have to just know that there are some kind of limitations. And while two of the main of those are that we still have gravity during that simulation, and we are lacking here, at least for the moment, a source of ionizing radiation. If you need if you need for me more information, you can always contact me. I have left on any slide kind of information that you can contact me, and I'm ready to answer your questions if you have any. Thank you.